Good afternoon class, welcome to our next lecture of non-destructive testing. In this lecture we are going to see what are the false indications in liquid penetration technique, as well as we will see the introduction part of magnetic particle inspection technique. So let us first see what are the false inspection techniques or false things which we generally observe in what we say in liquid penetration technique. If you see, the very first thing how to identify is when we are going to use liquid penetration technique, the very first thing we generally do is we used to have a penetrant. Okay, after that we use apply some amount of developer, so that developer and penetrant will together show the indication. So what is this false indication is nothing but these indications will give you the false results of your cracks. So how this generally happens is when you are applying the penetrant, so then penetrant, when we are washing off and you are trying to clean by using a water washable, or either you are using solvent reagent, or by using some kind of liquids, when the surface will not be properly cleaned, or the penetrant which is left out will give you some kind of false indication. So see here, the false indication is an accumulation of penetrant caused by the drop of penetrant left on the workpiece. So when some amount of penetrant is left out on the workpiece, that will surely lead to some kind of false indications, because the penetrant only will give you the indication of the when developer is added, they will react and they will show you the indication. However, there are two conditions which may create accumulation of penetrant that are sometimes confused with the true cracks and the discontinuities. Okay, the first includes the indication caused by poor washing. That is the first thing. When you are not properly cleaning the surface after applying the penetrant, it may cause you for false identification. Next is the other one is which the other one may cause it when parts fit to each other. For example, you are having a fits like a tolerance fit or any type of fit you are having. So generally in fits, what we have, if you have two shafts and the rod connected to one another, if you remove that, there will be some empty space left out. So because of the shaft, if there is a what do we say, tolerance fit, there will be a small gap. So in that small gap the penetrant will go. When you are applying the developer, that will show you the effect. Okay, if there is a wheel press fit on a shaft penetrant will show an indication at the fit line, means when they are able to sit with one another at that gap. When there is a press fit or when it is a tolerance fit, what happens means at the point where they have joined or conjunction is happening, there will be a small gap. When penetrants are added, the penetrant will go into the small gaps and it will show you as a discontinuity or a crack. Okay, but these types of indications are easy to identify, because you know that when you are doing two things are added or joined by use of some kind of fits, you can able to analyze, yeah, this is a fit because this kind of indication is coming because this is one type of fit, this is not a crack, that you can able to understand. But anyhow, it will, if some person who is a new person, he cannot able to identify. So however, if in terms of indication, that is also a false indication, it should not be showed like that. Next, what are the safety precautions that should be considered, that should be taken care when you are using liquid penetration inspection technique? Is the very first thing is flammability. So when you are carrying out this kind of experiments or this kind of test, you should use because solvents, I have given the example of solvent. If you are using an acid as a solvent or something, you might have noticed that you should keep the doors open, so that the whatever the gases formed, that should be escaped from your room. Similarly, when it is a flammability or when you are using some kind of things, so there you must use some kind of exhaust fans to disperse the vapors. Similarly, ignition sources should be avoided. For example, if you are using some kind of solvents, those solvents should not be in such a way they should be used, they should not be easily ignited. Means if you are using some kind of solvents which can easily capture the fire at room temperature or at some high temperatures, so such type of solvents or such type of penetrant should be avoided. Okay, next is skin irritation. You should be much aware, because these are mostly chemical things, that is penetrant or a developer is a chemical things. You should protect yourselves from by using gloves in your hands. Similarly, by using safety glasses to protect the eyes from the splashing. Generally, when you are cleaning the penetrant, the thing which is you are washing and fly into the droplets can go into your eyes, which can cause skin irritations or which can cause your eye loss. Similarly, ultraviolet rays. So the lamps gets heated up. So when you are using ultraviolet rays, So I told that the visual inspection can also be done by using UV rays. So when you are passing UV rays, the lamps get hot, so they should be very much cautious. Reports missing or cracked fills on lamps. UV rays can cause sunburn and eye damages in filters, so you should be avoiding all these things. Now, what are the typical examples or the applications of liquid penetration technique where we are generally using this is, first thing is aerospace. For example, in aerospace where we are generally use turbine blades, because turbine blades are continuously exposed to the various types of stresses. Okay, so once we are making or casting the turbine blades, we are using it under a high temperature. When aircraft flies to a greater height, what happens is at the greater height it may react with any of the gases present at the high level altitude. At a high temperature, the material can easily react. So because of that reaction or because of that what we say high temperature, it may create some small cracks on the turbine, which you should be absorbed before you are taking to take the flight for the next time. Next is rotor disc. Similarly, the rotor disc which is carrying the turbine blades. Next is aircraft wheels, casting things. When you are casting something and you are going to use it somewhere, you should be very much cautious. Next is forged things, which when you are making something by using forging technique, forged parts. Similarly, weld assemblies. So these are the things which generally used in aerospace, and you should be very much careful, and it should be tested in a liquid penetration inspection technique. Similarly, automobiles. In automobiles, some of the parts are mostly made by using aluminum casting. That is nothing but your outer cases of the body, and by using forging techniques, generally like piston, cylinder heads are generally subjected to various forms of various forms of pressures and various forms of temperature variation, because during combustion the piston will be going a lot amount of pressure. So when it is undergoing such kind of pressure, we should be very much careful that it can be able to withstand, or it should be very much cautious when you are using the automobile. So those things can be measured using a liquid penetration technique. Next is railways. In railways, the cracks, that is fatigue, generally the railway track, locomotive tracks, bogies, these can be studied by using liquid penetration technique. Next is tools and dies. Next is inspection on reactors and the tank. This is the one most thing, that is, if you have a big nuclear reactor, if it has a small leakage also, the whole the reactant will come out of the nuclear reactor, and it can able to completely collapse the whole system. So the whole system should be very much cautious, and it should be continuously checked every time. Okay, now let us see the disadvantages and the advantages are nothing but limitations of this technique. It is simple but and inexpensive, but whereas it can be used only to detect the surface flaws. It cannot be used to see the flaws which are deep inside the surface. Next is versatile and portable, means it can be moved anywhere. Non-porous surfaces for materials, like if the material cannot be going inside, if the penetrant cannot go into the deep into the surface of the material, we cannot able to identify the cracks. Next is applicable only to ferrous, non-ferrous, non-magnetic compounds and complex shaped materials which are non-porous and of any dimensions. In this, surface cleaning before and after inspection, that is one of the main tasks. Before you are going for the test, you should be cleaning the surface properly, and after the inspection also you should clean the surface. Okay. Next is detects the cracks, seams, lacks of bonding if there are two materials joined together. If there is a small joining, for example, during welding you might have observed even though the material seems to be joined, if you see that, if you break the welding, you can see that there is no proper joining if there is a formation of some air gap or air bubble. Okay. So next, deformed surfaces or surface coating prevents the detection. If there is any deformed surfaces there, and if there is some surface coatings are there, that will not allow your penetrant to go deep into the surface. Okay. So next is magnetic particle inspection technique, that is, we call it as MPI. So if this is completely based upon your magnetic philosophy. Generally we know that in magnets generally the current flows from north to south and south to north inside the body. Okay. The magnetic particle inspection is governed by the laws of magnetism, therefore it is restricted to the inspection of only magnetic particles. By the name itself we can easily analyze that this is only used for magnetic particles, but not for non-magnetic particles. Okay, that is the biggest disadvantage of magnetic particle inspection technique. So what are the various types of magnet? We already know ferromagnets, paramagnets and dimagnets. Ferromagnets are nothing but which are having iron as a main constituent, generally like iron, what we say, iron components which are having like nickel, cobalt. These are having combination of iron into it, because of which they will conduct the electricity. Another thing is paramagnetic substances. Paramagnetic substances are nothing but those which are able to be magnified. Not magnified, which can be magnetized easily. Okay, the materials are those which are weakly attracted by the magnetic forces of attraction, especially austenite stainless steel. Diamagnetic are slightly repelled by a magnet and cannot be magnetized. It cannot be magnetized. It will generally be repelled. But whereas these are weakly attracted, but we can make the magnetized when we apply some kind of magnetic operations on that. Okay, the magnetic inspection is a non-destructive testing that is generally used to detect the deflections of magnetic field. This is one of the fastest and relatively easy to apply, and part surface preparation is not critical, because in this it does not require any kind of part preparation. In liquid penetration we observe that the part should be prepared very accurately, but whereas in this it is not a big task. Okay, these characteristics makes the MPI, that is magnetic particle inspection technique, one of the most widely used NDT technique. The material is generally used to inspect varieties of products formed because of casting, forging, weldments. So these can be studied. Many different industries use magnetic particle inspection for determination of components which are ready to use or which are fit for use. Okay, some of the companies which generally use are structural steels, automotive companies, petrochemical industries, power generation industries, aerospace industries, and even some underwater inspections can also be done by using magnetic inspection technique. Okay, this is the main principle of magnetic particle inspection. For example, if the material is a continuous one, what will happen? The flow will be like north to south and south to north. Okay, so this is the flux lines which are formed around the surface of the material. Okay, any material, if you directly take it as a ferro material, either it is a paramagnetic material. Okay, this kind of lines will be formed. Okay, so when there is a crack or when there is a small hole, what happens in this is, because of, we know that when we are having a continuous magnet, if you break it at the center or at any part, so for example if you take this part, we will show you one thing. So see, this is a continuous part. For example, if you are breaking at this point, so this is south, means obviously it will create a north pole at this point. Similarly, this is north pole, means here again a south pole will be generated behind the crack, after the crack. That is true. When you break a single magnet into two materials, it will create two poles, because magnetic poles are not unipoles. They are always two poles, north and south, always. They cannot exist as a single. Okay. So when it is broken along the length to completely two parts, so the opposite poles will be generated. Instead, if the particle is cracked, here the lines will be continuous, but because here the poles are opposite, what happens means they will be repelled, or they will be having a small deviation being created at this point. The fluxes will be coming out of the surface. So this, for example, if you are taking iron particles and are sprinkled on the cracked magnet, the particles will be attracted to the cluster, and cluster not only at the poles but also at the poles at the edges. Means generally if you sprinkle some kind of iron particles outside the particle, the materials will be attracted towards the poles. So if you generally throw iron particles, the whole particles will be accumulating at this point and at this point. Similarly, because it is having a crack, again the particles will be attracted toward this edges. This cluster of particles is much easier to see. Means all the particles will be coming and sitting here. With that we can able to see that there is a crack. Okay, clear? So what are the basic things which you should understand when we are studying about the magnetism? The very first thing is polarity. What is polarity? Nothing but the orientation of north and south pole. Next is magnetic force, the force of attraction or repulsion between the two poles. Magnetic field, it is nothing but the area surrounded around a magnet on which the other particles like iron particles can be easily attracted. Permeability is the material by which it can be magnetized. By using what technique we can be able to magnetize. Next, flux density. Flux density is nothing but the number of lines passing through the area, or the number of lines passing per unit area is nothing but called as flux density. Magnetizing force, the total number of lines. How many number of flux density? Again converted to magnetizing force, the total number of lines of forces making up the magnetic field to determine the strength of the magnet of attraction or repulsion is called as magnetizing force. Cohesive force is nothing but the ability of the ferromagnet to withstand an external magnetic field without getting demagnetized. Ferromaterial should not get demagnetized when you are applying some kind of external forces. So when this generally happens is when you are heating the material will lose its ferromagnetic nature. Next is retentivity, the ability of the coil to retain some of the magnetization within the core after the magnetization process has stopped. We know everyone knows that when we are trying to pass the current around the material, the current will produce the magnetic field and magnetic field will produce the current. These two are mutual. Okay. So in this retentivity, what we do is after even removing the magnetization process, that is nothing but even you remove some kind of techniques, that is generally we pass the current to make the material magnetized. Even though you off the current, there will be some kind of ability to withstand some magnetization. It will be again magnetized even you are not allowing the current to pass through it. That is called as retentivity. To some time, around like 5 to 10 minutes. For example, you are passing a current through a solenoid, it will get magnetized. If you bring it near to the magnet, it will absorb it. Okay. Or if you bring around a coin, it will be absorbed to it. Suddenly, if you are stopping the current, the coin will not be fall as soon as you off the current. It will hold the coin for some extent. It may be microseconds or it may be milliseconds. So after that only the coin will fall. Okay. So that is nothing but retentivity. Next is hysteresis. We have already exposed to this hysteresis any number of times. There is nothing but if you are magnetizing a material through a process, again you are demagnetizing a process through a different technique or same steps, but it will not pass the same line. It will be creating a curve like this. So everyone might have remembered this curve. You might have remembered this curve. This is called as hysteresis curve. So this is magnetization. When you are demagnetizing, it will not go to zero. It will come to some positive value. Again, when you are making demagnetizing, at some point it will become this. Again, when you are magnetizing, this will keep on achieving. So this kind of curve is called as magnetizing process. Generally, this happens in we can observe this type of things in what we say AC, rectifiers. Okay, half wave rectifier, full wave rectifier. You can observe in all these things. Next is residual magnetism. It is defined as amount of magnetism left behind after removal of external magnet. Retentivity and residual magnetism is same almost. Okay, so these are the basic things. No methods of magnetization. How we are going to magnetize a product. For example, the basic principle of magnetization is to produce the magnetic lines of forces across the expedited direction of a clock. If the likely crack direction is unknown, then the test may be performed in two directions. That is nothing but perpendicular direction. Magnetic flows. To make the component of magnetic circuit by effectively using it as a bridge of permanent or executive electromagnets. Means in this they are passing some amount of current through a particle. So because of that, there will be continuous generation of magnetic field. When this magnetic field passes through this conductive material, again because of this passing, it will be converted to a magnetic field. So generally, when the direction of current and the direction of electrons, we know that to pass electric current through a specimen, we should be broadly know that and the region where the cracks are to be expected. Generally, we know that in this direction the cracks are formed. So basing on that, you have to pass the current. Okay. So because of this passing of current, the magnetic field will be generated. You know already this. What is a AC generator? In AC generator, you are having like two magnets, permanent magnets, and you are having a series of coils. N number of coils will be there. Since you have kept the magnets in between them, this two will be having some magnetic field. As it is cutting, you should give a small rotation to this. What happens is this will attain a south pole, this will attain a north pole. So it will try to attract. So because of that, repulsions will be formed, continuous attraction will be formed. It will be rotating. So when it starts rotating and cutting the magnetic field, it will be getting magnetized and it will be having some amount of current which you can be observed at this position. Okay. So this is nothing but called as induced current. Next is electromagnetic induction. Electromagnetic induction, this is the best example of solenoid. So if you are having a round cylindrical rod, you pass through a series of wires or coils of copper. You pass current through it, some amperes of current. If you are continuously passing the current and if you brought a magnet around it, so as current is passing through it, the magnetic fields are generated around this. The magnetic fields are generated around the coils. Because of this, the whole solenoid will become magnified, and if you bring a magnet near to this, so either it will be repelling. So if it is repelling the north pole at this point, this is the north generated here. If it is attracting the south pole, then north is generated here. In this way we can able to identify. So in next class we will discuss what are the different methods of magnetization and how we are going to identify the cracks. Basing on that we will wind up this first. Thank you.